Hi everyone, welcome to Vishwablooms. So in this video we'll be looking at bridge course of mathematics after 10th, which is also going to be beneficial for class 10th, lecture 2. So in the second session of bridge course we are going to see LCM and HCF, divisibility rules and ratio and proportions. So we are going to see some new topics also, okay, something which we have not studied till our 10th. In these three topics, let's go a little deeper, very little deeper. Okay, so let's hop on to the topic LCM and HCF first. So LCM and HCF is very basic topic. We already know this topic, right? So generally, what is LCM? Least common multiple. So you all know this, okay? Very simple. You all know to find out LCM and HCF also, I'm hoping. Even though if you don't know, it's okay. By the end of this video you should be able to do it. Okay, so HCF is highest common factor. Okay, so when any two numbers are given to us, suppose A and B, if we are asked to find the LCM, then what it means is we have to find their least common multiple. Suppose 2 and 4, what is their least common multiple? It is 4, because see, just write down the multiples of 2. It is 2, 4, 6, 8 and so on. If you write the multiples of 4, it is 4, 8, 12, 16 and so on. So what is the least common multiple in the both things? 4 is the least, right? Common, whatever you are able to find, the least value is LCM. That only we will do. Okay, see, generally in this way you are not supposed to do, because big numbers you cannot find it, right? I am giving explanation actually what is LCM. Okay, now what is HCF? This is about factors. Okay, these are about multiples. No, now this is about factors. Same 2 and 4 we will take. What are the factors of 2? 1 and 2 itself, because it's a prime number, and for 4 it is 1, 2 and 2, so it's 1, 2 and 4 itself, right? So here you can see the highest common factor we have to find, not the least one. See, least common factor for every number is going to be 1, but here we are asked the highest, so 2 is the highest, so HCF is 2. So I hope you got idea what is LCM and what is HCF actually. Okay, I'm not talking about the ways to find out and all that, right? So basic idea you would have got, right? Yeah, so LCM, generally you will use the prime factorization method, right? That is the method generally used by every one of us for finding the LCM, like this. I hope you all got it. 2 ones are 2 twos are 2 ones are 2 ones are. This is what is the way we do, right? For HCF we can do it in multiple ways. First method is again prime factorization method is the first method for this also. Okay, so prime factorization. Okay, so how we will do if you asked the HCF of 2 and 4? How do we do? First we will do for 2, 2 ones are 4, 2 twos are 2 ones are. So 2 is 2, 4 is 2 square. So what is the HCF? 2. That's it, right? This is how we do. And there is one more method of doing HCF, that is long division. Long division method also we can go through. Like if I am asked to find out the LCM of 2 and 4, I have to take one number here and one number here, like division, how we do, right? So 2 twos is 4. So what is the greatest common divisor? HCF is also called as GCD, greatest common. I'll just write it here so that it will be noted for you also. Greatest common divisor. So that is what in this method that name will suit very well. See here, what is the greatest common divisor? You have to see. For the last one, whatever you get, no, that you have to do. See, this is a easy one, but if I will give other numbers, big numbers like 21 and 2, or else let me take 21 and 6 simply, just okay. So 6, 21, we know 6 3 is 18. Okay, so you will take that 3. Again you will take this divisor as the this divisor as a dividend you will take. Okay, so 3 2 is 6. So what is the HCF? If you ask, no, you should say this, not this. Okay, you should say this. This is the GCD. I hope you understood the way to solve, right? So two methods are there for finding HCF, and for LCM I told you. LCM can be found out by, separately doing the prime factorizations also. So these are the methods, nothing new. I hope you all are clear. Maybe long division some of you might not be knowing, but I hope I made it clear. You should be doing more and more problems on that, then you will get easily. Okay, it's like division only, nothing nothing differs, but it's okay. Now one more like formula only we have to think. It is very very important to remember that if we have to find the LCM or HCF of, let us assume two numbers, let that be A and B. Okay, the HCF of A and B into LCM of A and B is just the product of those two numbers. This is very very important, and we already know this. If you're not knowing it, you should learn it. That's it. Okay, so this is very very important because you can solve many problems using this thing, because we already learned. It's okay, but now it's time to learn something new. If somebody has asked you to find out the LCM of, suppose, A by B, comma C by D, comma E by F, how will you find it? You don't know, right? So there is one formula, okay, for fractions. So that formula is also very very important, and you need to know that. So how you will find is, you will first find the LCM of A, C, E, those three top numbers, divided by, you will find the HCF of the denominators B, D, F. Understood? So this is one formula, very very important. If you want, we'll do one problem on each, okay, because we need to cover more topics in less time. Let's try to do that, right? Now LCM and HCF of 12 and 36, very simple. 12 can be written as 3 into 4, so 3 into 2 square if I have to write it in prime factorization form. Am I correct? Now if I am asked to find the prime factorization of 36, simply I can say it as 9 fours, right? So 9 can be written as 3 square, 4 can be written as 2 square, so no issue. Now if I am asked the LCM, how will I find out? What is the highest power in 3? 3's highest power is 3 square. 2's highest power is 2 square. Just multiply that. What is it? 9 into 4, that is 36 is the LCM. Now if I am asked the HCF, the lowest into 2 square into 3. What is it going to be? 2 square is 4, 4 3 is 12. That's it. Got it? That's all is LCM and HCF. Now just now I gave one formula, right? I mean, I didn't give, it was there, like I told you, right? That formula, how do we apply in the questions? Once we'll see here, same form, it is A by B, C by D, and E by F. In that form only it is there, right? So let's apply the formula here. First we have to find the LCM of 5, 11 and 2. And then we have to find the HCF of 7, 13 and 9. Sorry, 1 second, yeah. 9. Okay, so first finding the LCM of 5, 11 and 2. So these three are prime numbers, first and foremost thing. So when you do the prime factorization, that numbers only you will get. So you simply just multiply. See, whenever you see prime numbers, no, and you have to find the LCM, simply multiply. That's the best thing you can do. So what you will get? 5 to 10, 10 into 11 is 110. Okay, that is the LCM of the numerator. Now HCF of the denominator, see, you see that again 7, 13 and 9, these are again prime numbers. So prime's HCF is obviously going to be 1, because the factors are themselves, right? Themselves and 1. So simply put down 1. Okay, so whenever you're seeing prime numbers, you're going to use these tricks. Okay, this will help you and in saving time. See, whenever the LCM of prime numbers, whenever you're seeing, no, simply multiply. Don't waste time on doing. Okay, LCM of primes. Now HCF of primes, simply just write 1. Close your eyes and write 1. That's it. Okay, these things you should remember. Okay, very very important. Like, not very important, but it will save you time and calculation, right? That's what. So simply you can use that. Okay, I hope problems are clear, some examples are given, right? So next we will see the second topic which we have to discuss, that is divisibility conditions or divisibility rules. So for why should we learn divisibility conditions and rules? See, suppose there is a big number 5, 4, 3, 2, 1, 0. Suppose this is one number, and if you have to divide it with some number like say 2, then you should be able to know, right, first whether it will divide or not. Okay, 3, 4, 5, 6. Now 2 you maybe you will know. Okay, but for other numbers, see, dividing and seeing is time waste for all the thing, right? If you keep on divide for each and every number, it will waste your time. So if you know the conditions, you can save some time actually. See, if you don't know the divisibility conditions, what is going to happen is, if I have to know this whether this number is divisible by 2 or not, I have to do division like this: 5, 4, 3, 2, 1, 0, 2 ones are 2, and so on. It will take very long time, right? But if I know the divisibility condition, by seeing or by doing some little calculation only, I can say whether this is perfectly divisible or not. Okay, sometimes you will get a reminder for some numbers. That is again time waste for you, right? For that purposes, we will learn the divisibility conditions. Okay, first for 2, what is the divisibility condition? A number to be divisible by 2, the units digit should be divisible by 2. That means, simply in simple words, if you ask me, it should be even first and foremost. Very simple. Even numbers are simply divisible by 2. Or else units digit, if it is even also, no problem, that's it. Units digit should be divisible by 2. Okay, then it is the whole number will get divisible by 2. This numbers, if they are there, no, simply you can say. Understood? For 3, for 3 a number to be divisible by 3, the sum of the digits of the number should be divisible by 3. Didn't understand? Okay, wait, I will just write it. Sum of digits of number should be divisible by 3. This is divisible by 3 means then it is possible. Now if I give a number like maybe 120, okay, let me give a number as 123. Now should I want to know whether this number is divisible by 3 or not. How do I get to know? Add the digits of the number. 1 plus 2 plus 3. 1 plus 2 is 3. 3 plus 3 is 6. 6 is divisible by 3. So this number is divisible by 3. That's it. Understood? Simple things and matter. Okay. So now we will look at the divisibility condition for 4. See, for 4, what is the condition is, last two digits should be divisible by 4. That's it. Divisible by 4. Then the whole number is divisible by 4. Suppose if I have this much big number, I can simply say, yeah, this is divisible by 4 because last two numbers is divisible by 4, right? 24. That's it. So it will save our time. Okay, this is divisible by 4. Next, for 5, it is very simple. A number which if it is divisible by 5, then its units digit, if you observe, you will see. That's it. Units digit, it should be either 0 or 5. That's it. If it is other than this, it is not divisible by 5. 550, it is divisible. 555, it is divisible. Whereas 553, no, it is not divisible. These two are divisible. That's it. Next, the divisibility condition for 6 is very simple. Okay, this number should be divisible both by 2 and 3. If it is divisible means, then only it will be divisible by 6. Okay, see, generally 6, what is 6 actually? 2 into 3. See, right, a number which is both a multiple of 2 and 3, then only it will be multiple of 6, right? That's what. It's very simple logic. Okay, there is not a big rule, but if it is divisible by both 2 and 3, then only it is divisible by 6. Clear? That's all. We're not a big thing, it's a small one only. 7 is little bit complicated one. Okay, So this 7, no, I will try to explain with an example, then it will be, clear for you, I think. Okay, suppose if I have a number 770. I know you will say simply 7 sevens only are there, you don't take. Okay, I'll take a different example then. Okay, then let me take 763 as the example, because now you might not be knowing this. Okay, see, now 763, how do we know whether it is divisible by 7 or not? First, what you have to do is take the units digit and multiply it with 2. Okay, and subtract with the rest. Understood? 76 minus 2 3 is 6. 6 is equal to 70. See, this number, if it is divisible by 7, then the entire number is divisible by 7. So 70 is divisible by 7, so 763 is also divisible by 7. This is a trick actually for 7 table, because generally for 7 table it is really very tough to get whether it is divisible by 7 or not. It's a very big deal actually, so you should remember this trick. It will really help you, I'm telling. Okay, the statement, okay, you can just simply note it down in this way, however you understood. Okay, if you want one more example, again I'll give 770. Okay, so 0 into 2, what is it? 0 only. So 77 minus 0 is 77. Suppose you don't know that 77 is divisible by 7 or not. Again you have to do the same thing. 7 2's is 14. So 7 minus 14 is minus 7. Minus 7 is divisible by 7, yes. Okay. So if you don't know that number, again you should continue the process. Okay. I hope it is clear. I don't know. Now 8, a number, if it has to be divisible by 8, the last 3 digits must be divisible by, the last 3 digits of a number should be divisible by 8. Okay, that's all is a condition for this. Suppose if it is 3 4 5 6 8 1 6, see 8 16, you have to do division like this. 8 16, 8 ones 8 and 0, get down 16, and what you will do? 2 1 0 2. Okay, so that's what it is divisible, right? So that's why it is divisible, the whole number will be divisible by 8. I hope it is clear to you. I'll erase this. Yeah, now we will see the divisibility condition for 9. So for 9 also similar of 3. 3's rule and 9's rule is similar. Okay, sum of digits should be divisible by 9. Okay, divisible by, if it is divisible by 9, then only it is possible. Suppose 9 19. So 9 plus 1 10, 10 plus 9 19. So this is not divisible. Okay, so if I have 9 18, yes, this is divisible, because 9 plus 1 is 10, plus 1 plus 8 is 18. So 18 is divisible by 9, so it is divisible by 9. This 9 18 totally. Okay, so next we have 10th, actually 10, divisibility rule of 10, I forgot, okay, to mention. Nothing, very simple. Units digit is 0. Very simple, no? That's all. Okay, for 10. For 11 it is little bit again complicated. The difference between the sum of digits at even places and the sum of digits at odd places is 0 or multiple of 11. I know you would not have understood anything, just note that if you need. Okay, so I'll take an example and show 1 2 9 8. Okay, so what are the odd places and even places? First you need to find. These are the odd places, 1 and 3. First place, third place, odd places. Second place and fourth place are even places. Understood? So first what you should do is should sum it up, summing the even numbers. First sum of even numbers here, even digits sum. So 2 plus 8 is 10. Sum of odd digits, digits at odd places, 9 plus 1 is 10. What is the answer? What you have to do is you have to do difference between them. So 10 minus 10 is 0. So it's a 0. So it is a multiple of 11, and this is also a multiple of 11. Understood? I'll give one more example if you need. Okay, I'll give 1 to 2 1. Okay, now again these are the odd places, these are the even places. Sum of digits at odd places, it is first even you should do. Okay, first even. Remember, first sum of digits at even places, that is 2 plus 1, it is 3. Sum of digits at odd places, again 2 plus 1, it is 3. So 3 minus 3 is 0. That's it. Sometimes you will get a multiple of 11 also, but here we are getting 0, so not an issue. 0 is also multiple of 11, obviously. Okay, so with this we closed the divisibility rules topic. So we'll move on to ratio and proportion topic. So first we will see what is a ratio, and then we'll go on to proportion. So in ratio and proportion you're going to see some new topics, some new things. Okay, so you need to be very attentive in this part. Okay, so what is ratio generally? So ratio is comparison of two quantities of same kind, or like same kind in the sense having same units, is said to be a ratio of that particular quantities. So we used to find ratios of so many things, right? We have been finding so many ratios, right? Even the how much the line is getting divided, that ratio also we have seen. 1:2 ratio, 3:2 ratio, line division ratio also we have seen. So many ratios you have seen up to now. So the definition is this one. Okay, comparison of two quantities of same kind. So whenever if we want to express ratio of A and B, we represent this in this way. A is to B. We say it as A is to B or A ratio B. Okay, we can say it in any way. Okay, so that is one important thing. And ratio of anything is nothing but this A is to B can also be nothing but A by B. It is nothing but A by B. And in this ratio, this A, that is the first number, it is called as antecedent, and second one is consequent. Antecedent and consequent, these are the two things which we need to know. Maybe previously we might not be knowing it, but we should know by now. Okay, so that is very important. Now this is a new topic, types of ratio we never studied, right, in the 10th until 10th standard, right? First is compound ratio. So what is compound ratio is, if A is to B and C is to D are any two ratios, then AC is to BD is the compound ratio. Okay, so I am writing here, if A is to B and C is to D are any two ratios, then AC is to BD is compound ratio. Then what is duplicate ratio? See, if A is to B is any ratio, A square is to B square is the duplicate ratio. Again, if A is to B is any ratio, root over A is to root over B is subduplicate ratio. Again, if A is to B is any ratio, B by B is to A is its reciprocal ratio. These are the four ratios. I hope it is completely clear to you. Okay, compound ratio, duplicate ratio, subduplicate ratio and reciprocal ratio. Okay, next we will see one small problem based on this. Question is, find duplicate ratio of y is to x if 4y square minus 9x square is equal to 0. So first we will solve this in order to do problem. 4y square minus 9x square equal to 0. I am sending minus 9x square to RHS, which becomes plus 9x square. Now he is asking the ratio in y is to x format. So I will keep the y here and send this x to LHS. So y square by x square is equal to 9 by 4. Okay, so this is the y square by x square, right? So this is only the duplicate ratio. Generally y is to x is normal ratio, right? That is going to be 3:2. Just to say, you will have to root on both sides, then you will get this one. Okay, So y is to x is actually 3 is to 2, but I asked the duplicate data. Duplicate ratio is y square is to x square. See, duplicate I asked. That's why answer is, what is the answer? Final answer is 9 is to 4. Okay, because I asked duplicate ratio, not the simple ratio. Okay, so that was one question based on this. You can do many if you need, but it's not much necessary as of now. Okay, just for reference I have done, because I have explained about them, so I need to show one problem, right? So moving on, we have proportions. Expressing two ratios or expression of any two ratio is proportion. Okay, so if I say if A is to B and C is to D are two ratios which are equal, then A by B is equal to C by D. That is what it implicates, right? It implies. That is nothing but AD is to BC. So how AD is to BC? I will tell. Sorry, AD equal to BC. AD equal to BC here. Okay, equal to, that is. See, you will cross multiply, right? So it is going to be AD is to BC only. Sorry, equal to. First equal to is there, no? Keep it like that only. If you cross multiply, you will get that only. AD equal to BC. That's all, right? That's what I have written there. Okay. Now, how do we represent if A is to B and C is to D are in proportion? We will represent it in this way. A is to B, proportion, C is to D. We need to know 2 points actually. So about inverse proportion and direct proportion. Direct proportion and inverse proportion we have already learned, right? So if y is directly proportional to x, so direct proportion means that if one value is increasing, the other one also will be increasing only. Inverse means if one is increasing, other one will decrease. Okay, I'll explain that also, no need to worry. So if y is directly proportional to x, then y equal to kx. So I'll explain this way, where k is a constant. So first let me assume y to be the let them be number of chocolates and x let it be the number of biscuits. Say I have a number of chocolates as 4 and number of biscuits as 2. If I am saying that I have increased the number of chocolates by 2 times, okay, so 4 2s is 8. Obviously the number of biscuits also will be increased by 2 times, so 2 2s is 4. Here y4 is equal to 2 into 2, right? 2 times, so its k is something constant. Here also 8, it is 2 into 4. So this value is completely fixed, and this is the number of biscuits, this is number of chocolates. Understood? So that is what here we are applying and understanding by this step. Okay, now if y is inversely proportional to x, that means if y is increased, x will decrease. Okay, then y equal to k by x, where k is again constant. Okay, so k is again constant. Okay, so in a similar way you can understand this also. Okay, so these are something which you can remember, or you can just directly get it. Okay, next we have some type proportions. Note point actually, if A is to B and C is to D are in proportion, then we have 5 major rules. These are very important. This we will be using in trigonometry chapters also. You will be using it in your 11th standard trigonometry chapters. You will simply write using alternando, using dividendo, using alternando, componendo and dividendo. You will not mention steps. Okay, you will directly write the statement and you can use that identity. So that time when your teachers are explaining, you should not be confused, right? So that's why I'm telling it before itself. Okay, now if they are writing it as using Invertendo rule, then it means that this ratio you are making it ulta. See, A is to B, you will write as B is to A, proportion D is to C, ulta you will write. That is Invertendo rule. Next is Alternando rule. That means alternately you will put it in proportion. That is A is to C, proportion to B is to D. Okay, alternate means alternate values or digits. Okay, So componendo is a plus b by b equal to c plus d by d. Okay, see now generally it is a by, for general format is a by b equal to c by d, right? This proportionality means. So what you will do, if you are writing using componendo, you will add up to the numerator, add this to the numerator and write. Okay, now dividendo is something ulta, just a minus b by b equal to c minus d by d. Now componendo and dividendo means in the numerator you will apply componendo, in the dividend, that is in the denominator you will apply dividendo. A plus b by a minus b equal to c plus d by c minus d. This you will apply. These are very important. You will use it in your many upcoming chapters in your intermediate and 11th standard and 12th. Okay, so be aware of these things. Okay, so thanks for watching our video. Do like, share and subscribe to Vishwablooms. Bye bye.